So our next presenter is also a member of the LD4 program committee, whose work we're really, really grateful for. And he's a metadata librarian at the University of Colorado Boulder. His interests include digital collections, critical theory, and metadata infrastructure.
Everyone, can you hear me okay?
Yes.
Okay, great, thanks. Thank you, Christine, and the conference for having me. Again, my name is Eric Radio. I'm at the University of Colorado Boulder. And today I'd like to talk about applying minimal computing to ontology design. And there we go. Specifically, I'd like to synthesize two different areas of thought that at first glance might not seem to be totally related, but I think that by the end of this presentation, their connection will become clear. Specifically, I'd like to provide a brief introduction to the concept of minimal computing, explaining its origins and some of its implications, and how they can reorient us towards more sustainable approaches for digital projects. I'd then like to draw a line to the realm of linked data to see what applicability minimal computing concepts can have on our shared interest in this field. My argument is that the way in which we model our world, our ontologies, have direct and sometimes unforeseen effects on the infrastructure needed to realize these visions, and that minimal computing can help us to reduce complexity as we concretize those understandings into ontologies. So minimal computing as an area of concern emerged in 2015 through a piece by Alex Hill at Columbia University. The core of this thought revolves around two concepts he explores, that it is first the application of minimalist principles to computing, and then secondly, a reflection on what is actually needed to realize a given project. The framing of what do we need comes from Ernesto Arosa's ideas of architectures of necessity. And this quote from Arosa sums it up very well. He says, "On the one hand, it can be read as a descriptive term, austere in its rhetorical value, almost obvious. On the other hand, the term enunciates an architecture that is itself diagram, and this image becomes structural and programmatic. I believe that architecture should be that. The home must be a structure of agreements, a factual connection between needs, materials, technology, urban regulations, and social conditions." So as Hill notes, if we orient ourselves by this question of what do we need, it makes it easier to understand how ease of use, ease of creation, increased access, and reductions in computing can be achieved. And while this concept emerged in the digital humanities, I believe it is applicable to pretty much any field that uses a computer. As such, what is needed for a project is necessarily subjective. Being prescriptive in this regard would not be helpful, as what is needed differs by situation. However, I have found the minimal principles of Jennery Sayers to be a valuable contribution to the exploration of minimal computing. I'd like to explore just a few of his definitions that I believe have direct impacts on linked data. The first is minimal design, or reducing the need to update or modify the structure or layout of a project in order to focus on content production and to increase the likelihood of project persistence. For linked data, I think we can see this especially in the tools we build to make linked data and disseminate it. In other words, at what point does the complexity of those systems endanger their persistence and longevity into the future? The second principle I'd like to draw from Sayers is minimal maintenance. For linked data, I think this can readily be seen in the technology stacks that make linked data available, in addition to the ontologies we use. For example, how flexible are the ontologies for handling variants of the world that they model? Or how many different APIs from different platforms do we need to write separate code for to be able to ingest data? The third principle from Sayers I'd like to address is minimal obsolescence, or reducing turnover of technologies, standards, and formats to increase reuse and decrease waste. This is sort of self-explanatory, but think about how many ontologies were developed about a decade ago and how many of them are actually still being actively used. We can think of these unmaintained ontologies as not only a type of waste, but also as a type of noise that can confuse the landscape for those trying to figure out what is still being maintained. Oops. And finally, the last principle of Sayers I'd like to examine is maximum justice, which is reducing the use of technological, cultural, social, and economic barriers to increase entry, access, participation, and self-representation in computing, and to also build systems premised on social justice and difference and not white supremacy and settler colonialism. I think this is very important for understanding what barriers and complexity have already cut off certain parts of the profession, let alone the population in general, from using linked data, and how we can identify where our work is enabling others to join in these efforts or is actively pushing them out. I think it's especially interesting to view these concepts in light of some of the challenges linked data presents. The following list is in no way exhaustive. I wish these were the only challenges that linked data faced, but they illustrate areas where, in my opinion, complexity, and more accurately, potentially needless complexity, has made difficult problems even more challenging. From ontology mapping, which was a problem before linked data, to URI reconciliation, stack maintenance, ongoing training, and the economic frictions that at times seem to be pushing linked data in directions at odds to its original principles. That is, towards increasing centralization despite decentralizing principles. These are all areas for which a minimal computing lens could help clarify and ask us what is really needed to make linked data work for everyone. And I think that this quote from a study on challenges in linked data points to an important overarching concern. Aside from concrete issues of noise, oftentimes data are modeled in a manner that is not facilitative to generic consumption. For example, common properties for labels are not reused, properties and classes are invented and not defined, and insufficient links are given to enable data discovery, etc. From this observation, I'd like to go a step further and specifically ask, in the context of linked data, not only what is needed for it to work, but also to what end. In my opinion, if this work doesn't benefit our users in some tangible, material way, then we have more difficult questions to ask about the direction we want to take linked data. So now, while we could spend a very long time investigating all of linked data's challenges and applying minimal computing to help find answers, I'd like to explore just one area of linked data for which I think it is uniquely valuable: ontology design. So many decisions cascade from how the real world is defined in ontologies, and minimal computing has much to offer towards simplifying these models, infrastructures, and conditions that they necessarily require. The number of classes and properties one defines has direct impacts on the computing power required to process that data, let alone reconcile it with other data sources, which at the end of the day translates into more carbon dioxide into the atmosphere. In a very real sense, our models of the world have an impact on the state of the world beyond just how we are representing it. For example, the escalation of CO2 in the atmosphere has accelerated the rapid melting of glaciers. And this is actually where I'd like to turn now to explore a project at CU Boulder specifically focused on the melting of glaciers and how ontologies fit into this. So you can see here, this is the Andrews Glacier in Colorado from about 50 years apart. And you can already see that rapid change there, taken in the same month of those years. So a little bit of background data. The National Snow and Ice Data Center is housed at CU Boulder. And a few years ago, through a joint CLEAR grant between the NSIDC and the libraries, we digitized and made available over 25,000 glacier images, which documented them as far back as 1883 through repeat photography. One of the unique challenges encountered during the course of digitizing and cataloging these images was how to tie these glaciers together. With climate change, the ephemeral nature of these glaciers has really been laid bare. However, through repeat photography, we can see these glaciers melting decade by decade. In the context of this collection then, how is one to trace a line between the different iterations of the glacier to see how it has changed over time? Here, the rigidity of the collection technology doesn't allow for such a clear delineation. So naturally, an ontology would be a good way to tie together not only the different iterations of the glacier, but also the associated information about the glacier, like its data set and its representations, like these photos. But the question then is how to model a glacier. One critical feature of glaciers has to do with the nature in which they fragment. For example, the Andrews Glacier in Colorado could split into two smaller fragments. The fragments don't always get a name, but they always get a glacier ID. So how is the best way to model this? How do we show that relation between fragments? So when we were asking this question, we said, well, what do we do in the bibliographic realm for modeling this sort of thing? And so conceptual relations are no uncommon thing in linked data. We're very used to them. And to take just one example from the IFLA library reference model, we can see the familiar work, expression, manifestation, and item categories for understanding the relations between bibliographic entities. Now, obviously, articles and glaciers are not the same thing, but there is a similar problem between the two concerning how to relate the different iterations of each. And this is really the critical point. Where in the LRM model, these four categories all exist temporally at the same time. But for glaciers, there can be no moment when the original Andrews Glacier exists at the same time as its three fragments. You either have the entire Andrews Glaciers or you have the three fragments, one of which was the largest piece of the Andrews Glacier. The reason for this is that the LRM model is relying on abstraction. And to point out the obvious, of these four categories, only one exists in a physical way, the item. Just as for glaciers, there is no such thing as like a super glacier that we could use. There is only the Andrews Glacier and the fragments it created. And while we could certainly model it as a super glacier, we had to ask what would be the tangible benefit in doing so. Super glaciers don't exist. We can't visit one. So it's not quite right to say that something that doesn't exist has something that does exist. So with this understanding, we decided to try to orient our ontology in more material, concrete ways as we could. So we avoided abstraction in favor of foregrounding those elements that have concrete presence in the world, even if it's just a name inscribed on paper or computer memory. This had several advantages for us because, as we had learned through other projects, ontology mapping is never easy, but in our opinion, some of that difficulty can stem from ontological classes that are abstract in nature, trying to be mapped to another abstract ontological class in a different model. Since neither may exist physically, what they can always be changed by non-material conditions, and it's hard without a real anchor for them in the world. And so while we could have used a superglacier, we opted to not use classes that didn't have a real-world correlate. In our ontology, we then opted for omitting those abstract representations that could be as modeled with a real-world correlate. Just as in the bibliographic realm, we could perhaps give ontological primacy to the item and then spell out properties from there in the model. From a minimal computing perspective, we approach it from the question of what is needed. Do we need to have super glaciers, or is it enough to just show that fragmented relationship? And these are just two diagrams of the glacier ontology, which is still in draft form. This one is very small and hard to read, and here's a simpler version that omits a lot of the detail, but hopefully gives you a sense. And again, this is all in draft form, which I hope to release later this year. So to go back to the question of minimal computing, it was not so much a question of what did we do, but what didn't we do? So while this ontology may look quite pared down compared to others, our goal is to preserve necessary complexity while not contributing to it. To this end, I'd like to build on the work of Hill and Sayers by proposing two new principles for minimalist computing. The first is maximum materiality. And by this, I mean the start of any model or recreation of some aspect of the world should aim to primarily document material, physical aspects of entities in the world. To go back to a bibliographic example, subjects change, but the author usually does not. So prioritizing concrete fields might be a good solution for this. The second is maximum transparency. By this, I mean increasing the demarcation between those elements or properties that are based in concrete reality versus those that are interpretive. By this, we can avoid a reification of interpretive aspects in a project by outlining more clearly that which is physically descriptive and that which is interpretive. So what do these principles perhaps look like in practice? Let me first start by saying that abstractions are necessary for making sense of the world. I'm not advocating for us to stop thinking in abstractions because I don't even know, that's not even possible. But there are going to be instances in which abstract properties are going to necessarily be part of an ontology. But my point is to first identify what are the material or physical properties that we are trying to model, and to emphasize those first as the basis from which other properties can potentially be developed. From there, an abstract property might emerge, and we would then need to ask, what purpose does including this property serve? This is a difficult area that we need to be very honest with ourselves. For our line of work, I believe that this must necessarily be tied to serving the researcher or the information seeker in some way, as this is what I think is at the core of our profession. From this, we can say that if it does serve a researcher or an information seeker, does it also generally serve society as a whole to make this data available in this way? This is difficult but crucial. As abstractions are not necessarily real-world entities, we run the risk of making real or concretizing into existence something that may not have the effects we intend. To use a very tame example, the red panda has been through the classificatory roller coaster several times, starting off as raccoons, before then becoming bears, and then finally into its home-specific family that I'm not quite sure how to pronounce that, so I'll just leave it right there. But it's important to remember here that with these different categories come different environmental protections. And it's not difficult to see how categories that get concretized in the real world have direct implications for similar things like gender, race, and class. To that end, transparency requires a necessary historical framing so that the interpretive aspects can be better seen and understood. Another example that is a little bit closer to our daily lives has to do with the concept of social network, as another example of this reifying or concretizing process of a concept. So for example, social relations have always existed, but it was in the early 20th century that the concept of the social network became an object of academic study. From there, as a concept, starting in the 1960s, there came interest from corporate strategists in the network as an organizing principle. So we've moved out from just observing social relations as an object of study, but into a method of production, which led to the reification of the social network, not only in organizational practice, but later in the internet through concrete materializations of networks. So think of Twitter, Facebook, and Instagram. These are all concrete networks that produce data that continuously feed back into the concept, which not only produces capital, but allows the definition of networks to change in ways to further benefit capital. And so there are a lot of different directions to examine with this materially oriented approach. This is really the first exploration I've done into a synthesis of these two fields of minimal computing and linked data. But I hope this discussion has illuminated at least one way in which minimal computing principles can provide a valuable lens on the effects on how we model the world and how that cascades into very real decisions about the technologies and infrastructures we use to build our network projects. So I look forward to hearing your thoughts on this, and I'm happy to take any questions.
Eric, this is great. So there aren't any questions in the Q&A box yet, but we will just wait patiently while people type. And we have a question from Jesse Lambertson.
Okay.
Thank you, Eric. What do you think about mapping via URI the current URI for each glacier and its fragments, but then with a history of the URIs that disappear as the fragments disappear? This could still map a relationship, but also a relationship over time relative to the tracking of actual objects in space-time. You brought up interesting socially relevant questions for sure. Thank you. And this question has been asked on Slack as well.
Oh, okay. That was a really good question, and I'm not sure I caught all of it, but I think I'll try to address what I think I remember, and then if I didn't catch something, just ping me again. So I think if I understood the question, it was kind of how do we think about URIs in sort of a temporal sense as well, because I think that that's another way that we could potentially model these things to kind of, I think, hopefully show transparency with that. And actually at this conference last year, I was talking about glaciers because that's all I can talk about these days is ice and the melting of ice. And so I was, in that presentation, I was specifically thinking of what do the temporal models for linked data look like right now? And there is not a lot of agreement between the different major ontologies that are out there. And, you know, kind of one of the main bifurcations has to do with the model of time people want to use. One of which is the perdurant model, and one which is the endurantist model, and one of which says that, you know, things exist sort of in blocks and chunks, and another one says, well, things are kind of always developing and continuing. And so there's really important kind of philosophical decisions that stem from each of those that you make if you choose one of those. But I think the fact that there is quite a variance in between, let's say, SIDOC CRM and something like Bibframe, and how those kind of implicit ontological temporal understandings figure into those ontologies, it makes a different level of complexity beyond just the ontology mapping. And so it'd be one thing to say that if one ontology for glaciers uses an endurantist model and another one used a perdurant model, well, we'd have a problem because there's multiple competing ontologies, but trying to map those even in an atemporal sense would be difficult. But then when you factor in time, it adds in another dimension. So I'm not sure if that answered your question in any way at all, but I'll look on Slack too and talk with you further if I totally didn't address that in any way.
Yeah, Jesse says, feel free to go further in Slack if you want to, no worries.
Okay, cool.
So let's just give it another minute for more typing. Question from MF. Are there specific Bibframe changes you would like to see based on these principles, or a way to use these principles in evaluating future requests to change Bibframe? Great question.
Yeah, that's a really good question. And I purposely didn't want to, you know, poke at any one large ontology too much, but I think that, you know, ontology mapping is difficult, even just thinking about IFLAR, LRM, and Bibframe and how the different classes are not the same. I think that that's, you know, that's a challenge in its own right. But I think for something with Bibframe, for which we have, you know, we do have the physical item, but we also have those two other levels that are not necessarily things that are, you know, tangible that something can hold. It's really important for us to ask, you know, what, there is an abstraction that we're using here, and what is the benefit of keeping this abstraction in place? And, you know, there's lots of very good arguments for that. And I think that, but I think that there's probably different ways that those classes can be revisioned, maybe in ways that do have a more tangible material out effect for users. I'm not sure off the top of my head necessarily what changes I would want to make right now, if I had any at all. But I think that engaging with that question of, you know, what does the work mean for our student who comes into the library if they aren't necessarily aware that that concept is being used to show them some work in the catalog or the system that they're using. So I think that I don't have any necessarily proposed changes right now, but I think it's an interesting, I think all ontologies are really a good place to apply a minimal computing lens to see sort of, you know, what is actually needed for the user, and what does it take to get there to accomplish that. And I think that for the original origins of minimal computing, which was in the digital humanities, it really was envisioned as, you know, what we want to have a digital collection online or a digital exhibit. And what happened was, you know, we're all familiar with Omeka as a very common system in the library, but in most libraries I've worked in, there's usually like 4 or 5 different versions of Omeka that are floating around. And that's a lot of complexity. And, you know, Omeka is a very user-friendly system, but there's a lot of computing that's happening underneath it that is not simple at all. And so from that, a lot of people move towards, you know, static websites like Jekyll to present digital exhibits online or to put a digital edition online. So I think that I think looking at how minimal computing has been used in digital humanities can also serve as a lens for us to see, well, how did people actually reduce complexity in this field where it emerged, and what could that possibly mean for us?
Thanks, that's great. So we have a sort of follow-up question that I feel like this bleeds into, which from Mark McGee. Are there any benchmark libraries / linked data projects you've seen that you think implement minimal computing in a good way?
That's a really good question. I think that there's probably not, I mean, the answer is I don't know if there's one that I could say like, here's the perfect example of minimal computing, because this is only something I've thought about over the past, you know, since like January or something like that. So a further exploration of kind of this lens onto kind of the bigger models is something I'm planning to do in the future. But I think that there's probably aspects in a lot of different ontologies that can apply minimal computing, that do apply minimal computing lenses very well. And, you know, something like, say, SIDOC CRM again, which is, you know, a very, very complex ontology. That's like, but I think that what's really great about that is that there seems to be very good reasons for everything that they have included in that model. And so it's not necessarily like, for me, when I think about what ontology is doing this best, is the one that has the fewest number of properties. I think that it's, but way I think about it is more about which of these properties are actually, you know, really essential, and which actually preserve complexity that is really valuable, like a valuable type of complexity, and which ones maybe have complexity that is not necessarily going to have, that might be, you know, interesting for us to use, but isn't going to necessarily have a a tangible effect on people who are using the ontology and don't even know necessarily that they're using that in a system. So sorry if that didn't answer your question, but I'm happy to talk offline too.
Thanks. It's not an easy question to answer. So another question from Leslie Johnston. How would you apply the minimalist principles to a non-physical item ontology, such as a graph of distributed online resources with several potential but not required one-to-one many relationships?
Yeah, the non-physical thing is really interesting. And I think that a really good person, I think, to kind of think about, we think about computers and computing as sort of amorphous, oftentimes very ephemeral things. And I think that is true. But I think that for me, I've kind of understood this from the framing of Matt Kirschenbaum, who in his book Mechanisms and other writings has, said that computers do have like materially inscriptive events that happen inside them. The memory is inscribing something, and there's lots of interesting forensic arguments for how that is the case. And so I think that there's not necessarily, there's obviously a difference between, a physical book and an ebook online, but I would argue that they're both material, tangible things. It's just their mode of use is a little bit different. And so I think that that's a really fascinating question, though, and I have to think a little bit more about it. But I think if I was going to approach that question more concretely, I would probably approach it from kind of that aspect of rethinking or remembering that the computer is a tangible material thing, and that things on the web, on the computers, are materially inscripted objects.
Awesome. So we should start to wind down here. There was a question that came, there's another question that I think we have time for, from Tharwa Al-Alemi. In your opinion, how can we use IFLA LRM in a practical way to change the bibliographic control in the library integrated systems? Or do we have to wait for Bibframe?
Oh, I don't know. That's a good question for like 2 minutes. I think that, I think one of the real strengths of minimal computing is to say that it's not, here's what minimal computing means. It's XYZ, you have to do XYZ, make sure you only have 15 properties. It's really what is needed in a given situation. And I think that quote from Arose really spells this out in a really great way, because he says that it's a descriptive term, and it's really about, what makes sense in a given place and a given time, what is needed in your context, because my context in CU Boulder may not be the same context as somebody in the University of California. That might be in totally different things. And so I think approaching that question of, is there a way that we can turn IFLA LRM and use a minimal computing lens on it? I think that there probably is. I think there's a minimal lens you could apply to probably almost anything, but I think it also is very site specific, in that, it has to be what makes sense for your users, what makes sense for you, given, your technical constraints, your resources and all that, because those things are not necessarily going to be the same from one place to another.
Great, and then we had one more question that came in through chat from Alexander Provo, and she's asking, is there a link to the slides? So if you could drop that into, if you happen to have a link to the slides available, if you could drop that into chat, that would be awesome, or Slack.
Yeah, I can do that, and I'll put it on the conference website too.
Thank you.
Okay.
Great, so if you're ready to unshare your screen, Anna Marie, who is up next, is going to share her slides. Eric, thank you so much for this. This was fantastic.
Thank you. Thanks for having me.